In this video, we're going to compute the inverse of a 2 by 2 matrix. We're going to do it using a very general algorithm that you can actually use to compute the inverse of any square matrix. In the next video, we'll actually use a closed form equation that lets you really easily compute the inverse of a 2 by 2 matrix. But first, let's just work it the general way so we can see the general strategy for computing a matrix inverse. So here's the matrix A that we're going to work with. Matrix A is 4, -2, 2, 3. And we are going to compute the inverse of this matrix as long as it exists. So if the inverse exists, we are going to find A inverse. So the first thing we need to do is check for the existence of the inverse. Well, that's pretty easy to do. If we compute the determinant of the matrix and the determinant is non-zero, then we know that the inverse exists. So let's go ahead and compute the determinant of A. So in dealing with 2 by 2 matrices, computing the determinant is pretty easy. It's just this element times this element minus this element times this element. So you kind of cross multiply these two diagonal terms and you cross multiply the other two diagonal terms. So for this specific case, determinant of A is going to be equal to 4 times 3 minus a -2 times 2, which is 12 minus -4, which is 12 plus 4, which is 16, which is not 0. So since the determinant is not 0, we know A inverse exists. So let's go ahead and compute A inverse. So the general way to do this is to create an augmented matrix that has A, the matrix you want to invert, as the first half, and then an identity matrix as the second half. So this right here is a 2 by 2 identity matrix. It's a matrix that has zeros everywhere except ones down the diagonal. So we've created an augmented matrix that has the form of A in the first half and I in the second half. What we're going to do is we're now going to perform row operations on this matrix to turn this matrix into a matrix that looks like A inverse. So our goal is to manipulate the front half into the identity matrix. When we're done doing that, once we've obtained an identity matrix right here, then this, by definition, is the inverse that we're looking for. So let's go ahead and start working on that. We need to turn this into an identity matrix. So the first thing I'll do is multiply the first equation by 1/4. So there's the first equation multiplied by 1/4. 4 times the fourth is 1, a -2 over 4 is a -1/2, etc. Now I'm going to go ahead and let equation 2 equal equation 2 minus 2 times the first equation. So I'm going to force a 0 right there. So equation 1 remains unchanged. Equation 2, that's a 0. I'm going to end up with 3 minus 1, which is 3 plus 1 is 4. And you can see how the rest of those fill out. So we have a 0 where we want it. Now let's go ahead and multiply equation 2 by 1/4. Let's go ahead and get a 1 right there. So equation 1 remains unchanged again. Equation 2, we multiply everything by 1/4. So 0 over 4 is 0. 4 over 4 is 1. A -1/2 times a 4th is a -1/8. And 1 over 4 is a 4th. So we're almost there. We just need a 0 right there, and I can get a 0 there if I let equation 1 equal equation 1 plus 1/2 equation 2. So equation 2 is going to remain unchanged. Equation 1, I'll have a 1 there, because 1 plus 1/2 times 0 is 1. I'll end up with a 0 here. The next element will be 1/4 plus 1/2 times a -8, which is a -16. So I end up with 1/4 minus 1/16. We'll simplify that in a minute. And then finally, 0 plus 1/2 a 4th is an 1/8. So I end up with this. Let's go ahead and get common denominator and simplify just a little bit. A 4th minus a 16th is actually 3/16. So that simplifies there. And then the rest of this just remains unchanged. A -1/8 and 1/4. So we've now manipulated our starting matrix into a matrix that has an identity matrix right there. So there's our identity matrix. This, by definition now, is A inverse. So we have determined that A inverse is the matrix 3/16, 1/8, a -1/8, and 1/4. So this is the inverse matrix that we were looking for. So that's the general way to solve for the inverse of a matrix. You just form an augmented matrix, and then you perform row operations to make the first half into an identity, and then by definition the second half is the inverse that you're looking for. In the next video, we'll take a look at how to compute the inverse of a 2 by 2 in kind of a closed form equation that's a little more simple.